knowledge. In business, it drives innovation and competitiveness, and in our personal lives, it helps us make better decisions and adapt to change. Hi friends, I am Professor K. Muralidharan of Maharaja Sayajirao University of Baroda. Today, I will explore not only the steps involved in problem solving, such as identifying the problem, generating possible solutions, and evaluating outcomes, but also the mindset required to approach problems with confidence and resilience. So, it is better to watch the video of my own, which was posted some days ago, that is on Statistical Problem Solving 1, where I had explained the step-by-step approach to statistical problem solving. So the link is provided here. Although it is not required, but still it's better to watch that video first. So what is statistical problem? It's the process of using data and statistical methods to understand a problem, make decisions or draw conclusions based on evidence rather than guesswork. So it's not just doing calculations, but it's a structured way of thinking that combines statistics, content knowledge that can be borrowed from any discipline and subjects, measurement and critical reasoning. So a statistical model can be expressed in the form y equal to f of x1, x2, etc. xn plus epsilon. So you can see three types of variables here. Y is your dependent variable, x1, x2, etc. xn are the input variables, and epsilon is your error term. And presence of epsilon decides the whether model is going to be good or bad. So that term is also called nuisance term, disturbance term, error term, or simply like that, or even uncertainty term or random term. And that term is very important in statistical modeling. So let us assume that you have a practical problem, convert that into statistical problem. And for that, you need to have some good knowledge about statistics. So understanding the problem, practical problem, and converting that to a statistical problem, it's really a challenge, no doubt. But with experience, one can have it. Once you have the problem in statistical sense, you can definitely look for a statistical solution. And once that solution is obtained, you can go for practical solution. So this is the whole problem solving approach or DMAC problem solving approach. You can always say from that point of view, from Six Sigma philosophy point of view, DMAC, define, measure, analyze, improve and control. So what you are finally doing, you are finally constructing a model in the form y is equal to fx plus epsilon. So let us look at an example. So I'm going to show you how this can be solved or how the problems can be approached with various ways. Okay, so it includes a descriptive way, how a businessman look at the data from their perspective, how a clinical trial scientist look at the problem in a different sense, how a statistician, how a mathematician, how a physicist look at the problem. So various approaches can be possible. Okay, so the problem is about a tire manufacturing process. What is given is inner radius in centimeter. Okay, so 10 samples each from 3 shifts are gathered. And if the variation in shifts are discarded for the time being, then can we conclude that the process conforms to the standard of inner radius 35 centimeter? So the manufacturer has clearly mentioned the specified limit, specified targets per se, that is 35 centimeter. Okay, so let us see how this can be approached. So here is the descriptive method. So get the descriptive strategies. This can be done in Excel software also. So various measures of characteristics and estimates are given here. So what it actually gives? So mean plus or minus 1 standard deviation. The interval is given 34 to 35 something. Mean plus or minus 2 times standard deviation gives you 33 to 36 point something. And you can see that mean plus or minus 3 times standard deviation is going to be 32 to 37. So the percentage of observation covered by 1 sigma limit, you can say that is 70% observed, because 21 out of 30 observations are covering that particular interval. So plus or minus 2 standard deviation covers roughly 28 out of 30, that means 93.3 percentage, and 3 sigma limit covers roughly all the observations. So if you recall, the normal distribution has a very interesting property, that is area property, we always call it. So what it actually says, the 1 sigma limit covers roughly 65% observation, or 65 to 68% observations. 2 sigma covers roughly 95 percentage, and 3 sigma limits covers 99.9 percentage, something like that. Okay, so that means the intervals definitely covers the manufacturer's target, that is 35 centimeters. So we can very well conclude from a descriptive sense. So no more, no computation, no further computation, no scientific investigation as such we have done. Simple descriptive statistics based. So here is a slightly an advanced way of looking at confidence interval method. So we have 95% confidence interval and 98% 99% confidence interval given here. So we know the since the data follows a normal distribution, so we can always construct a confidence interval for a given significance level. So that is x bar plus or minus z alpha by 2 sigma by root n. So the z alpha by 2 is the critical point that depends on the value of alpha. So for alpha it is 1.96, the z value is from normal distribution, and 99% it is going to be 2.5. The interval definitely you can see there covers the process average. So definitely we can confirm that the process conforms to the standard of inner radius 35 centimeter. It is another method slightly related to confidence interval and confidence interval method. So not so looking the problem from this particular point is sometimes attractive and sometimes meaningful, and more justification can be thought of. So where the producer's target is 35, so let us put it that in the H naught. So your null hypothesis is mu equal to 35 against mu is not equal to 35, and with a significance level given alpha is 5%. So you can change alpha to any level, 10%, 1%, 2% even. The test statistics, because it is normal test, so it's x bar minus mu by sigma by root n, and that is coming out to be minus 0.77. So the procedure is that if absolute set is greater than or equal to 1.9, so you reject H naught. But here it is absolute set coming out to be 0.7057 something, which is actually less than 1.96, and therefore we accept the hypothesis. So the process conforms to the standard radius of 35 centimeters. Here is another approach, control chart, because we are slightly away from the normal inferential aspects. So we have the measurement on radius and it's continuous. So naturally we will go for control chart for mean. So, and before controlling X bar, or you can say mean chart, we generally construct the R chart first. If the variation is under control, and only then it makes sense to go for controlling the mean or target. So here you can see both the charts are shown here. There is no changes, abrupt changes. There is no any constant or any assignable causes of variation. Here the data points are strictly random and without following any pattern. So the once again it confirms the standard that it is going to be the radius is 35 centimeters. So what is the point here is that different approaches, different way of concluding the things, but most of the time the conclusions remained. But is it necessary? Not at all. So it can, the conclusions can change from topic to topic. Fortunately, here all the conclusions from all the inferential method problem solving approach, we got the same conclusion. So why we go for statistical problem solving? So it can quantify uncertainty. That's the most important part of statistical study. It reduces bias in decision making, turns data into actionable insights, helps in prediction and forecasting, supports evidence-based policy and decisions and strategies, and much more. So that's the importance of problem solving. So stay tuned for my next video on the same channel, elucidation and